Hi, today we're going to be talking about succession in an Acadian forest, monitoring the effects of Hurricane Juan on Point Pleasant Park over time. So, succession is an important ecological concept that describes the changes that occur within a community when it is exposed to a disturbance. Among the many disturbances that can induce succession, wind disturbance is one that is particularly impactful as it can cause significant vegetation loss and severely disturb soil. A major source of wind disturbance is hurricanes, which, due to their ability to remove large portions of forest canopies and cause landfall, are one of the most important disturbances for forests in Atlantic Canada. Point Pleasant Park is an urban Acadian forest located in Halifax, Nova Scotia. The park holds great importance to the Mi'kmaq Nation as the land, which is called Amnukati, meaning spiritual place or the place of spirits, was a traditionally significant gathering place. Prior to 2003, Point Pleasant Park was declared an even-aged, near-climax community. Due to this even-aged nature of the park, the forest had a strong canopy but few young trees to buffer against the winds, which ultimately meant that the area was highly vulnerable to windfall. Hurricane Juan then hit eastern Nova Scotia in September of 2003 with Category 2 force and wind gusts up to 185 kilometers per hour, making it the worst storm in Halifax history since 1893. The immediate impacts of the hurricane included the removal of over 70% of the forest canopy of Point Pleasant Park and the loss of about 70,000 trees. Previous research has showed that since this disturbance, the ecological community of Point Pleasant Park has changed greatly over time, and as we continue to gain more information about these changes, we are able to investigate the effects of succession over larger timescales. In this study, we are aiming to specifically examine the long-term effects Hurricane Juan has had on the overall forest community, the dominant species of the park, and the species richness over time. So based on what we know about succession and community metrics, we hypothesize that we will observe an increase in total density, an increase in red spruce and red maple populations, and an increase in species richness between the years of 2003 and 2025.
Data was collected from 6 chosen sites scattered around central and southern areas around the park. These sites were chosen based on the most affected areas or which showed most damage from the hurricane. At each site, a 20 by 20 meter area was sectioned with measuring tape, which was further divided to form 4 10 by 10 meter quadrants. Data was collected within these quadrants on percentage cover of ground flora and diameter at breast height of trees. To collect percentage cover of ground flora species, wooden 1 meter squared quadrats or frames were utilized. Sampling area was determined by throwing random object, and where it landed became the center of a sampling area. This was done 3 times within each of the quarters for a total of 12. Ground flora species were identified with their percentage coverage within the sampling area. The diameter of trees was collected and identified within the sampling areas. Trees with a diameter of less than 2.5 centimeters were excluded from collection. Trees were measured at breast height, which was about 1.3 meters from off the ground with specialized tape, which allowed us to measure the circumference of the trees to determine the diameter.
We use linear regression analysis of overall density over time to understand the secondary succession occurring at Point Pleasant Park in the wake of Hurricane Juan in September of 2003. A significant positive relationship was observed between time and overall density with an R-squared value of 0.45, an F statistic of 72.4, and a very small p-value, meaning that there is strong evidence that density increases over time. As made evident by the trend line in our total density graph above, overall density has increased since, with the most recent years showing the highest density. These results mean that we can reject the null hypothesis and that there is strong evidence that overall density of the plots sampled since Hurricane Juan has been increasing and is moving towards a climax community once again. There are a few reasons this has likely happened. First, post-hurricane, 30% of the trees in Point Pleasant Park were left standing. These trees likely provided a great base for which tree density could grow from in the years following. Additionally, the exposed soil resulting from the uprooted trees and the cleanup effort of the park post-hurricane would allow for plenty of space for which the seeds from these remaining trees could grow. Another reason for this density growth could be a lack of competition for space in the park. As the overall forest community moves towards its climax community, we can predict that biomass of early pioneer species will become less prevalent in the space and will make the environment more suitable for other species that are more tolerant to higher competition, since the focus will be less on disturbance tolerance and more on competition as density increases. Finally, we can predict that the overall biomass accumulation will slow down as nutrient cycling becomes increasingly efficient in the park.
A linear regression was conducted to analyze the density of the dominant species. Both red spruce and red maple have a p-value of less than 0.05, therefore we reject the null hypothesis in favor of the alternate with density increasing over time. This is supported by the positive relationship between species density over time. In 2004, red spruce was the dominant species at Point Pleasant Park with an average density of 3.25 in that year. As we can observe on figure 4, over the 20 years, the species density slightly increases to an average of 8.8 in 2024. Not that large of an increase, but understandable for the nature of the species as red spruce is very slow growing and only starts producing seeds at 30 years old, meaning that the trees that survived the hurricane at Point Pleasant are currently the only spruces that are producing seeds as new generation is still too young. In 2024, the dominant species is red maple. With an average density of 31.6 within the sampling areas, red maple has a rapid increase from their average of 0 in 2004. As they are fast growing and reach reproductive maturity at 4 years old, we can observe a spike in density just 10 years after the hurricane. If in the next 20 years there is no disturbance, many of the red maple trees will have reached maturity and dominate the forest canopy, matching the height of the original red spruce. Many of the newer red spruce will have reached seed-producing age and contribute to the increasing spruce population. In a couple decades, the species density will have reached an equilibrium where they have fully adapted to the changed environment after the hurricane, with red spruce dominating the forest as it is the climate species of the Acadian forest. Red maple will have declining density due to competition faced within the forest. Red spruce will have reached a similar density to that of before the hurricane. However, there are several factors that can prevent the forest from reaching climax community, such as increasing frequency of hurricanes and that the trees are susceptible to wind-thrown disease and insects.
We used a linear regression to analyze species richness in Point Pleasant Park over time, and this analysis is graphically represented by the figure here. This figure shows a clear positive relationship between species richness and time, as species richness increases drastically from 2003 to 2025. The p-value for the relationship is also far less than 0.05, which indicates that the relationship is significant. Due to this information, the null hypothesis can be rejected that there will be no change in species richness in Point Pleasant Park over time, as the data prove that species richness in the sample areas has steadily increased since 2003. Because species richness is a community metric, it can then be inferred that communities in Point Pleasant Park are recovering over time. These results are fairly expected when considering an environment in a state of succession. The minimal richness in 2004 indicates that the disturbance caused by Hurricane Juan left very little species variety in the park. The species that were left were also likely pioneer species with qualities such as shade intolerance, high seed dispersal and reproductive rates, and the ability to live in harsh environmental conditions, such as areas with poor soil and nutrient availability. The gradual increase in species richness then further indicates that over time, those pioneer species have been able to recolonize the area and restore environmental conditions to ones that support more species variety, likely then including more species that are persistent, long-lived, and shade-tolerant. As the forest moves towards a climax community, it can be predicted that the increase of species richness will eventually slow and reach a peak due to the environment's maximum capacity. Around this time, the forest will likely have reached community maturity and be mostly composed of a variety of shade-tolerant canopy species. Unfortunately, the increasing hurricane frequency in Atlantic Canada means that wind disturbance is becoming increasingly common, which may prevent a climax community from being reached anytime soon.
Based on the trends in the data and succession theory, we are likely in the earlier part of the middle stage of the Acadian forest secondary succession. We can see that the overall density and species richness over the past few years has stopped increasing as much as it was immediately after the initial disturbance, which is an indication that we have entered the transition phase between the aggradation and steady state phases of ecosystem recovery. Point Pleasant Park, being an urban park, affects succession in many ways. Part of the park's upkeep involves the removal of invasive species from the park. This assures the impacts of humans bringing in invasive species that could interfere with the natural selection will be minimized, since this is a popular tourist destination and there is potential for non-native species to be unintentionally introduced. Next, the existence of pathways in the park means that some seed distribution methods are favored above others, since it would be easier for unassisted and wind-dispersed seeds to make it across these paths than, for example, scatter-hoarded or ant-dispersed seeds. To close off, indigenous cultures have been practicing methods of ecology and forest recovery for almost 1,000 years now. One of these methods is two-eyed seeing, a concept brought forward by Mi'kmaq leader and elder Albert Marshall in 2004, which refers to seeing a concept from both a scientific point of view and an indigenous point of view. This could lend itself very useful to the recovery of Point Pleasant Park back into a mature Acadian forest, as we can learn to both integrate ourselves to work with the land as well as encourage it with scientific processes. Our first question was, based on your results, do you think human activities in Point Pleasant Park are helping or slowing the forest from reaching its climax community? In 2008, researchers found that natural succession is occurring in the park and that it wouldn't take extensive restoration efforts for the park to undergo succession. They did suggest that fences be erected and occasional trees be planted to support the natural succession, which is what the park ended up doing, having planted 70,300 trees in 2007 and 2008. Seemingly, this helped with the park's regeneration, as it's been about 20 years since the initial disturbance of the park, and based on our results, we've concluded that we are in the middle stage of an Acadian forest secondary succession. This means that the initial aggradation is complete, and now the park just needs its ecosystem to stabilize. Based on this, I would say human activities have helped and will continue to help the forest reach its climax community.
The second question is, based on your research, do you think a second disturbance in the park right now will show a similar curve as to what we saw over the last couple of years? As stated in our introduction, Point Pleasant Park was classified as a near-climax community according to the Ecological Survey of the park published in 1992. I don't believe if a second disturbance would yield the same results with the forest currently being in an intermediate community. The forests now and then have different biodiversity and species abundance. However, if we were to deploy the same recovery strategy, it is possible to receive the same outcome. Another factor to consider would be the type of disturbance experienced. If it's another hurricane, its curves would be different to if it were a fire or a flood. A fire disturbance would have a higher tree survival rate depending on the species, and during recovery will have a higher density of species with seeds that germinate when burnt. This would have different abundance and density curves to a hurricane disturbance, where trees are susceptible to winter and completely uprooted.
And lastly, I'll be answering the question, what are some examples of ways the concept of two-eyed seeing has been put into practice in the restoration of Point Pleasant Park, and how else can this perspective be integrated into the way we interact with our environment? So as mentioned above, two-eyed seeing, or Aduaptamumk, refers to the Mi'kmaq idea of approaching the world with the perspective of both traditional indigenous knowledges and Western knowledges. After Hurricane Juan, Point Pleasant Park was closed for 9 months for cleanup, following which a comprehensive plan was put in place to manage and maintain the park long-term. To create this plan, input and consultation from First Nations groups was critical for the development and implementation of the methods for managing the park. This input, combined with Western scientific understandings of conservation, culminated in restoration practices that included protecting the existing remnant forests, guiding natural tree regeneration, monitoring understory vegetation, and eliminating invasive plant species. The long-term plan for the park also included the recognition and preservation of historical sites within the park that are significant to the Mi'kmaq community, as well as the creation of new spaces in the park specifically for education about Mi'kmaq traditions. The concept of two-eyed seeing is extremely valuable as it forces individuals to consider ways of thinking from multiple perspectives, thereby making that way of thinking inherently stronger and more informed. This teaching can be integrated into most interactions that we have with our environment, but especially in the way we approach education about the environment. By combining our scientific knowledge of ecology, for example, with the knowledge developed over hundreds of years by First Nations communities, we would be able to build an understanding that is even more complete and comprehensive.
We would like to thank Dr. Joanna Zaguris, as well as demonstrators of Class Biology 2060, especially Jovia Gallant, for the logistic help they provided in data collection in the field. We are also grateful for the help provided by every student that helped collect data on this project since 2004. Additionally, this project would not have been possible without the constant upkeep of the park, a service provided by the Halifax Regional Municipality's Point Pleasant Park team. Finally, we would like to acknowledge that the land on which this project took place is on traditionally Mi'kmaq territory.